Hello everyone, welcome back to lecture series on linear algebra. Guys, in our today's video, I'm gonna explain to you all how to find the rank of matrix, okay, by using echelon or canonical form of a matrix, okay. Might be I already have explained in my channel some of the videos like this, but if you want to see similar videos, go and check in my playlist. Or in our today's video, guys, I'm gonna explain to you all detailed understanding for echelon or canonical form of a matrix, okay. Yes, it is very easy, guys. We have to find out the rank of matrix using this one, okay. So what actually the echelon form of matrix or canonical form of matrix? The echelon or canonical form of matrix A is a row equivalent matrix C, okay. It is a row equivalent matrix C of a rank R, okay, and which is having some of the standard property. At least one of the element in each of the first row R should be non-zero, okay. That means at least one of the element in our row, at least it should be a non-zero, okay, and remaining element can be zero possible. The second property we can say, in the first R rows, the first non-zero element in each row is 1, okay. If the non-zero element and each row, it should be equal to 1 and it appear in the column right to the first non-zero element as the preceding row, okay. So you will be confused like this many properties, okay. I'll explain with one of the short simple example, okay. So consider this. I will explain to you all echelon or canonical form how it look like, okay. So take the example A. I consider the example A as a echelon or canonical form, okay. Mostly you have to reduce the matrix A into it, or maybe if any zero row available into our matrix, it comes at the ground or downside here, okay, at the last row, okay. It exists at the last row, okay. So A11, consider this, we have entire non-zero row A12, A13 up to A1n, okay. This one is a entire non-zero row, okay. Make sure that, okay, first leading element we want the 0 here, okay. Leading element should be 0, okay. So this one is a pivot element, okay. A11, A12, we call it as a pivot element, PIVOTE, okay. This one is a pivot element, okay. So leading element should be non-zero, okay. A23 up to A2n, okay. So leading element should be non-zero, okay. So you consider this one 0, this one 0 up to all are element 0 up to A third row nth column, okay. And similarly, if any 0 row which is available, it should be at the end of the matrix, okay. That means end of the row of matrix, okay. This one we call the row echelon form, okay, or echelon form of the matrix or canonical form of the matrix. It is quite easy, guys, or might if you feel anything confusing, once we solve some of the example, you come to understand, okay. Yes, make sure that we want leading non-zero entry of A as a pivot or pivotal element, okay. Leading non-zero entry, okay. Leading non-zero entry, that means A11, A23, A3n, these are the leading non-zero entries for rows, okay. That one we call the pivot or pivotal element, okay. Yes, so similar we have row echelon form. Inside the echelon form we also can come to see like a row echelon form as a point, okay. So row echelon form means 0 rows, okay. If exists, there is a 0 row at the bottom, okay. If the 0 row exists, it should be at the bottom, okay. That one is a row echelon form, okay. Leading non-zero entries, okay. Leading non-zero entry in a row is a right to the non-zero entry, okay. So that means it should be a non-zero over here, okay. Right to the non-zero entry, this one non-zero. So after this we want the non-zero, after this we want non-zero, after this we want non-zero, okay. Yes, so pivotal element we want non-zero, so that means A11 we want non-zero, A23 non-zero, A31, these are the pivotal element we want the non-zero, okay. Or maybe each pivotal element can be 1, okay. Yes, these are the basic concept that we need to know for the echelon form of the matrix. See guys, I have added some of the properties for echelon or canonical form of the matrix. Okay, leading non-zero entry of A, we call it as the pivot or pivotal element. Okay, so if any zero row exists, it should be bottom, at the bottom. Okay, if exists, it should be at the bottom of matrix. Okay, and each pivotal element A is 1. Okay, maybe we want it is 1. Okay, that means this one, this one, this one. Okay, yes, that one we call the echelon or canonical form of the matrix. Okay, yes, so I hope you all have understood echelon and canonical form of the matrix. This is like a little theory part, guys. Might be it is quite confusing to understand, but in our next lecture I'm gonna explain to you all with some of the example, so that concept will be the crystal clear for every one of us. Okay, so we'll see that part in our next lecture. I hope you all have understood the echelon or canonical form of the matrix. If you don't, then let me know in my comment section. Give me the comment what you feel difficult. I will come up with the similar videos. So that's it here for our today's lecture, guys. Thank you everyone. Thank you for my today's lecture.